Today we'll be looking at physics, paper 4. We're looking at 2018, May, June 2018, paper 4-1. Oh, let's take a look at some of the parts. Well, today's one will be part 1, and we will try to finish this paper maybe within two videos. Okay, now the first part we will be looking at this question, which without much ado, let's begin. We say figure 1.1 shows the speed time graph for a vehicle accelerating from rest. The vehicle is accelerating, so when you see a curve like this, the vehicle is accelerating. So it's accelerating from rest. This is the speed axis, the vertical axis is the speed axis, and the horizontal axis is the time axis. So this is the speed time graph. When you have a speed time graph, the area under the graph becomes the distance traveled. The area under the graph becomes the distance traveled. Okay, this one, the gradient of the speed time graph is the acceleration of the motion, acceleration of the vehicle. Okay, it's the acceleration. The gradient of the graph, of the line, of the curve, it's the acceleration. Now I say calculate the acceleration of the vehicle at time equal to 30 seconds. So at 30 seconds, we're going to draw a tangential line, because you cannot calculate the gradient of a curved line unless you place a tangent, on it. Okay. Okay, so we're going to find at 30, we're going to draw a tangential line, a straight line like this. See, we're going to locate 30. This 20, this 40. So 30 will be like 2.5 box. There's the 1 box. There are 5 boxes between 20 and 30. So 30 will be 2.5 box away. You draw it. Okay, to meet the curve. Where it meets the curve, you put a point there. And then you take a ruler to draw a tangent line, a line like this, a straight line like this. Okay, you use a ruler to draw a tangential line, and then we calculate the gradient. We'll draw a tangential line at 30, then we'll be able to calculate the gradient. Probably the gradient will be 30 minus 5, probably 30 minus 5, that's 25 over let's say 60 minus 0. 60 minus 0. Okay, so 30 minus 5, probably, let's say we say assumption, because we did draw the graph. Okay, let's say the vertical side is 30 minus 5, for example, the gradient 30 minus 5 over 60 minus 0, for example. So we will get 60 minus 0. This will be the acceleration of the vehicle. 60 minus 0. Okay, this for acceleration. Acceleration is the gradient of the tangential line. When you draw a tangential line, you have to draw a tangential line, because when you have a curve, you must draw the tangential line in order to be able to calculate the gradient. This is the curve. You have a curve. Okay, you must draw a tangential line. So at point 30, you must locate that point. When you locate that point, and then you draw a tangential line. You draw a straight line. Okay, to pass a tangent line to pass through that point. Has to pass through the point. Okay, it has to touch this point. Okay, the line has to touch. And then once that is done, then you can calculate the gradient like this. So the gradient is equal to 25 over 60. 25 in this regard. 25 over 60. 25 divided by 60, what do you get? Divide by 60. Okay, 0.41. Okay, we can say 0.42 meter per second square. meter per second square. Okay, the range of the answer for this, meter per second square, because it's acceleration. The range of the answer should be from 0.3, okay, any student gets 0.3, all the way to 0.45, all the way to 0.45, you consider correct. Will be considered correct. So anyone gets 0.3, all the way to 0.45 meter per second square, will be considered to be correct. Okay, so that's the acceleration of the vehicle at this point. That's the acceleration of this vehicle moving at this point. So the acceleration is 0.42 approximately, or 0.416, as the case may be. Okay, so that's the first question that we've been asked to solve. That's the first question that we'll be asked to do. Is that okay? Now the next one is without further calculation, state how the acceleration at time t equal to 100 compares to the acceleration at time t equal to 10. Suggest in terms of force a reason why any change has taken place. At time t equal to 10 will be this point. Okay, when the vehicle was just the third box, middle of the third box. Okay, when the vehicle was just started to accelerate. At time t equal to 100, we'll be tracing it to this place when the vehicle was close to reaching its maximum acceleration. So you can see there's a big disparity between these two. So they're asking us to state the difference. Without you calculating, you just look at the graph, state how the acceleration at time t equal to 100 when you compare it to acceleration at time t equal to 10. Suggest in terms of force, and this is why the change has taken place. Okay, acceleration at time t equal to 100 is slower because you're reducing. Now the vehicle is reducing. See, at 100 the vehicle is reducing almost to a constant speed. It's reducing, so it will be slower. Here it's faster, it's 33, it's fiery. The vehicle is fiery. Okay, here the vehicle is fiery. Okay, at this point equal to 10, the acceleration, the vehicle is increasing. This is called increasing acceleration. This is decreasing now, about to be decreased. Decreasing acceleration, or is slow. So we say the first thing, the acceleration at this point, say the acceleration is less or at a slow rate. We can write the acceleration is less, or we say it's at a slow rate. The first point we write. Question B. We write A. This is our question 1A. Okay, now let's do our 1B. 1B, we say the acceleration is at a slower rate. We say acceleration is less. So we can use, I use A for acceleration, okay? We say acceleration is less. Is less. We say acceleration is less. Okay, this one is less, okay? Don't mind the marker, is just writing anyhow. Acceleration is less or at slower rate. Or you can write slower rate. Acceleration at 100 is at a slower rate. The vehicle is about to slow down its acceleration, or it's already started slowing down its acceleration. So we say acceleration is at a slower rate. Is at a slower rate, or is beginning to reduce this change its speed. It's beginning to reduce its speed. Okay, so that's the first one. But you have to write, if it's more than 1 mark, we have with 1 point is not sufficient to get more than 1 mark. You can see the question gives 3 marks, so we must give 3 points. Every point you get a mark, so we at least give 3 points. The second point, we can say, remember they asked us to talk about in terms of force, so we can say that less driving force. Now the force is less, and because the acceleration is getting less, so you also use less force. At 100, at time t equal to 100 seconds, we say less driving force. The driving force will reduce. The driving force, this is logic based on the question. They say we should talk in terms of the force. The driving force will be less. So we say less driving force. Okay? We say less driving force. Now we move to the third point. We must give 3 points in order to get the 3 marks. Okay? If they give 2 marks, you just give 2 points. Okay? So we say The next one, the resultant force is also less, because we're practically speaking in terms of force, right? Less driving force. What about the resultant force? What about the resultant force? The resultant force, so I write F resultant, I write FR. F resultant, I write it like this. Resultant force equal to less, because the driving force is now less, hence the resultant force will be less. Okay, I just try to abbreviate so that we can move faster. So less resultant force. So we've answered that. We get these 3 marks. We put it in the bank. We put it in our success account. Okay, success account, meaning we get these 3 marks. If we can give these 3 points, we get these 3 marks. Okay, if you can get these 3 points, you get. If a question carries 3 marks, you must give 3 points. If a question carries 1 mark, just give a point. A point is sufficient. You move on so that you can save time. You move on for that question so that you can save time. Now let's move to the question C, 1C. Let's move to 1C. Okay, 1C. Question 1C, the question says, let's take a look at the question. The question says that determine the distance traveled by the vehicle between time 120 seconds and time 60 seconds. So we're going back to the graph. The distance in the speed time graph is area under the graph. So we have to calculate the area under the graph. So between 120 and 160, you can see is a trapezium. Between 120 and 160 is a trapezium. We can break this trapezium into 2 and solve rectangle and a triangle. A rectangle and a triangle. Okay, so to find the distance traveled just from here to here, we have to calculate area under this graph. Okay, we have to calculate area under this graph. So if we come here, the maximum value here is 30. At this point is 20. So 0 to 20 is the first part. So if we come to our space, our working space, I'm only going to show the last part of the graph, okay? Not the whole graph. The last part of the graph says from the point here where the vehicle moved to this point. So we have this line. I'm only showing the last part of the graph, not the whole graph, okay, for easyability. Okay, so we have this. This is the last part of the graph. We have this shape from that part of the graph. Remember, here is 120. Here is 120. And here is 160. 160. Here is 160. And here is 20. And here is 30. Here is 30. So to find the distance traveled, we have to find area under this graph. We have to find the area of this shape. And to do that, we can logically break this into 2. We can logically break this into two shapes. Okay, one will be a rectangle, so I call this one A, I call this one B. So we find the area of a rectangle and we find the area of a triangle, and then we add the answers together. So area A okay, this one gets stuck. Okay, let's write another one. Area of A is a rectangle, so I can say A is rectangle is equal to length times width. Length multiplied by width. Okay, so from 120 to 160 is 40, right? This place will be 40, right? From 120 to 160 will be 40, and from here, which is 0, you know, it's 0 on the horizontal side. 0 to 20, here is 20. So this will simply be 40 multiplied by 20. Because this one, the distance from the bottom here to here is 20. So we say 40 multiplied by 20. 40 multiplied by 20, which gives us 800, right? 2 times 4 is 8, and then you put the 2 0. 800 meter. Let's just put the units of distance straight away for this one. Now we do the second one, the B. Now the B is the area of triangle. B is area of triangle. Okay, so which is half base times height. The area of B is equal to half base times height. Half base, half times B, the base, which is 40. The base is 40. Half times B times height. The height from 20 to 30, the height is 10. This height is 10. So this height is 10. So we're going to use 10, right? So we say, okay, this one changed from H. Okay, let's see if we can correct this. Okay, times height, H. Okay, so the next thing is to say half of the base is 40. The base is 40. Half times 40 times the height is 10 times 10 times 10. Remember, we're not looking at the whole height. We're looking at the height of the triangle. We're looking at this height only. We're looking at this height only, the height of the triangle. Okay, so half of 20, half of 40 is 20. So here we get 20. We get 20 here. So 20 times 10, we get 200. So area of B is equal to 200 meter. Equal to 200 meter. So we add them together, we get the distance traveled. We get the total distance traveled from 120 seconds to 160 seconds. So the distance will be distance is equal to area A plus area B. So A plus B, which is 800 plus 200, which is 1000. 800 plus 200, which gives us 1000 meter. Okay, so we get 1000 meters. So that's the distance that was traveled from 120 seconds to 160 seconds, or 1 kilometer. 1000 meter or 1 kilometer. So that was the distance that was traveled from here to here. Okay, so that's that for that question. So we'll move on to the next one. We'll move on to question 2. I think we're done with question 1. So here, this one you get also 3 marks. You get 3 marks here, and then you get 2 marks and 2 marks. I think, okay, 3, 3, and 2. That's 8 marks. So question 1, you pocket the whole 8 marks, and this is how to maximize your success rate. You have to get what you know right, and then probably you battle with what you don't know very well. Okay, so this is what you do. Okay, you have to make sure the things that are easy that you know, you have to get the marks. You have to maximize the marks, because if you start losing the things you know, obviously you're going to fail the things you don't know, and then your success rate becomes diminished, becomes slower, like we said in the earlier case. Now let's read this question. Figure 2.1 shows a forklift truck lifting a box. This is a forklift truck is lifting a box. Is what? Lifting a box. Now the electric motor that drives the lifting mechanism is powered by batteries. Now state the form of the energy stored in the batteries. Okay, this is pretty easy. Energy stored in battery is chemical energy. Okay, some people call it chemical potential energy. Okay, whether you write chemical potential energy or you write chemical energy, you're still correct. So the energy stored in the battery is chemical energy or chemical potential energy. So question number 2A. Question number 2A is chemical potential energy. Chemical For me, I just write chemical energy. Chemical energy. Energy stored in the battery. It's also potential because it's stored. It's not moving. So that's why we can call it chemical potential energy. Okay? Energy is stationary. So chemical energy. So that's that for that question. Now let's take a look at the next question. The big question. It said the lifting mechanism uses a box of mass 32 kg. So we have to take note of the parameters that are given. So we work from the known to the unknown. Through a vertical distance, that's h of 2.5 meter in the so number of time. So we bring out the parameters. Mass is what? 32 kg and h is 2.5 and time is 5.4. So we bring out the parameter. Question B. Question 2B, we said the mass is equal to 32 kg. The mass is equal to 32 kg. The mass is equal to 32 kg. And then we say the height is equal to 2.5. The height is equal to 2.5 meter, 2.5 meter, and the time was given, and the time it took to lift it was 5.4 seconds. 5.4 seconds. So they're going to ask quite maybe more than one question. Probably you calculate the energy and then you calculate the power or whatever. Let's see what they're going to ask us. Okay, so it's a the vertical distance means height. It equals 2.5 meter in 5.4 seconds. That's time. Now calculate the gravitational potential energy gained by the box. Okay, here gravitational potential energy, that's the first one. And then gravitational potential energy is mgh, right? The formula is mgh. So we use the abbreviation gravitational G, gravitational potential energy, GPE. We use the abbreviation GPE, that's the gravitational potential energy, is equal to mgh, is equals to mass times gravity. Mass times gravity is the weight of the object. Mass times gravity is the weight of the object, then you multiply the weight by the vertical distance. You multiply the weight by the vertical distance, then you get the gravitational potential energy. And this is equal to, the mass is 32, the mass is 32 kg, multiplied by the gravity they would give you, but for IGCSE we take the value to be 10. For A level, the value is 9.81. Okay, so for IGCSE we round it to the nearest whole number, so it's easier for our calculation. So we say times 10, then the height is 2.5. So you multiply this, what do you get? 32 times 10, you get 320. 320 multiplied by 2.5. So we get the gravitational potential energy to be approximately 800 joule. To be 800 joule. To be 800 joule. This will be 800 joule. Is that okay? You get 800 joule for the energy. Now let's say that's the B Roman figure 1. So there are two questions for B. let's look at the other one before we go to C. This one is Roman figure 1. Roman figure 1, the gravitational potential energy. Calculating the gravitational potential energy is B, Roman figure 1. Okay, let's see what else they will ask us to do. Other B, Roman figure 2. Now we found the energy B, Roman figure 2. Now we found the energy. The next question says we should calculate the gravitational potential energy, which is 2 marks. The efficiency of the lifting mechanism is 0.65, which is 65%. Calculate the input power to the lifting mechanism. Calculate the input power. So before we do that, we have to calculate the output power first. We have to calculate the output power before we can do the input power. We already have the efficiency. We need to have the output power, because efficiency is output power divided by input power. Okay, efficiency is output power divided by input power. So for us to calculate the output power, because they've given us we've got the energy, the gravitational potential energy, and we have the time. So let's calculate the output power. So our output power, since they say we should find the input power. So power, I write power in. That's input power. Power in is the input power. This is what they want us to find. We don't know this, but we know the efficiency of the machine. We know the efficiency. We know the efficiency of the machine. The efficiency is 0.65, or you say 65%. It's the same thing. 0.65 is the decimal equivalent of 65%. Okay, so we say the efficiency is 0.65. Okay, the efficiency of the machine is 0.65. Okay, then the output power, you need these 3 parameters in order for us to calculate anything. P out. So we call this one the output power, we call it P out. So we need to calculate it before we can find the input power. The output power, remember, is what they've given us from the parameters. Is what they've given us from the parameters. Look at it. We said the efficiency. Let's write the formula for efficiency. The efficiency of a machine is the output power over input power, or work done output work done by the output part of the machine over the work input. So we say this is P out. P out, that's the output power over input power. Efficiency equals to output power over input power, then multiply by 100. But in this case, we already multiply by 100 because we put it in decimal. Because 65 divided by 100, we get the decimal. Okay, so this is the formula. This is the formula multiplied by 100. This is the formula for efficiency. Now, before we can continue this question, before we can solve this, we put the efficiency value here, put the output power, we make the input power the subject of formula. Okay? So, before we can do this, we have to calculate, like we said, we have to calculate the output power. The output power, P out, let's use this place. The output power, P out, is our energy that we've calculated. The output energy, the gravitational potential energy that we've calculated, is equal to energy over time. And the time that was used, the energy over time. Okay? And this output power is equal to our energy, which is 800, right? Energy, which is 800, divided by 5.4. Divide by 5.4. 800 divided by 5.4. Everyone divide. Okay, so divide by 5.4. If you're watching this video, pause it now and do the division. So we will get what? Okay, so we get 148 watts. The unit of power is 1 watt. 148.1, probably 148. 148.148. Okay, which approximately to whole number is just 148. So watts. This is what we get for our output power. Now that we got our output power, we can calculate our input power. We can calculate our input power because efficiency is the output power divided by input power. P out divided by P in, that's efficiency, right? Okay, and we already got the output power. So let's do this and find our answer. So we substitute into this equation. Efficiency is 0.65. Efficiency is 0.65 is equal to output power. We got 148. Let's approximately 148 watts over this one we're looking for, over P in, the P in. So if we cross multiply, we get P in times 0.65. If we cross multiply, we get P in times 0.65. So we get P in, the input power, multiplied by 0.65, multiplied by 0.65 is equal to 148. Is equal to 148. So P in, that's the input power, the input power is equal to 148 divided by 148 divided by, or you say divide both sides by 0.65. 148 divided by 0.65. 148 divided by 0.65, what do we get? Okay, yeah, so this gives us the input power 227. We get P in, we get 227 watts. Point something, right? In physics, in IGCSE, they always round it to the nearest 10 decimal place. They round this one. So if you live like this, you are right. Sometimes in the exam paper, you see 200. It doesn't mean you are wrong, okay? They normally do this. They round this one to the nearest 10. Because they love numbers to be, if there's some, they will round to the nearest 100 if need be. Some they round to the nearest 1000, depending on the value. So since this is in hundreds, they round it to the nearest 10. They write answer like this. So it doesn't mean if your answer is this, it doesn't mean you are wrong, you are right, okay? In physics paper, they always like to round to the nearest 10. So whether you write 227 or 230, you are still correct, okay? Now let's go to the C question. We've done 2B. The C question says, so the input power is 230 or 227. The batteries are recharged from the main voltage supply that is generated in an oil-fired power station. By comparison with a wind farm, state one advantage and one disadvantage of running a power station using oil. Okay, what is the advantage of having a power station using oil and wind? So we will compare, right? One advantage is that if you're using oil, it does not depend on the weather of the place, or it does not depend on whether wind is blowing or wind is not blowing. For wind power station, it solely depends on the availability of the wind. Okay, it solely depends on the availability of the wind for wind one. So since we are looking for the advantage of oil, we say it does not depend. It does not depend on the weather, the wind, and so on and so forth, whether wind is blowing or not. So we say the advantage of oil, it does not depend on the weather of a place. Okay, it does not depend on the weather. For wind, it depends on the weather, right? The weather, whether the wind is blowing. It does not. So it does not. It does not. Okay, I will just write doesn't. Okay, for abbreviation for my own writing. But in your case, don't write doesn't. Say it does not depend on the weather. Or you can say it's independent of the weather. Does not depend on the weather. Or some can say it's independent. It does not depend on the weather. Does not depend on the weather. Okay, so this is one advantage of using oil. Advantage oil for power station. Using oil for power station to generate electricity. So it does not depend on the weather. Okay, so they just want one advantage for. So what would be the disadvantage? Pollution. Disadvantage pollution. Oil. When we say oil, we're talking about petroleum. Okay, pollution, SO2, CO2 gases, release of those gases to the atmosphere, which causes climate change. Disadvantage is pollution. Polluted the environment with SO2 gas and CO2 gas. And if I'm releasing all the greenhouse gases, okay, capable of releasing greenhouse gases. Number one, pollution. So they just want one advantage, one disadvantage. So pollution, releasing SO2, pollution. So we can put in bracket SO2 gas, release of SO2 gas, release of CO2 gas, even CO gas, carbon monoxide, carbon dioxide, all the release of these gases to the atmosphere, which are greenhouse gases, even methane, which is also a greenhouse gas, methane, CH4, you can write that, CH4. So all these are pollution, they are greenhouse gases which pollute our environment. This is methane, CH4. Okay, so this is the disadvantage for it. So let's move on to the next question. So we've answered this, I think we finished this question 2. Okay, now let's go to question 3. Let's go to question 3. Okay, question 3 says, a rectangular container has a base of dimensions 0.12 meter by 0.16 meter, and the container is filled with a liquid. Now the mass of the liquid in the container is 4.8 kilogram. Calculate the weight of the liquid in the container. Weight. So we know the mass, we can calculate the weight. Weight is mass times gravity. So we simply go and say question number 3. For question number 3, we simply say question 3a. The question is asking us to calculate, I think this 3a Roman figure 1, probably. Okay? 3a Roman figure 1 is asking us to calculate weight. Weight is mass times gravity. But before we start calculating, let's jot down the parameters that are given. Where the dimension was 0.12. The side of the shape is 0.12 meter by 0.16, right? 0.16 meter. And then they gave the mass. I think it's 4.8. The mass is 4.8 kg. It's filled with a liquid. A container has a base. This is the base, okay, of the container. And the container is filled with a liquid, and the mass of the liquid in the container is 4.8. So the mass of the liquid, so now calculate the weight of the liquid in the container. So the mass is 4.8 kg. the mass of the liquid is 4.8 kilogram. So now we're going to find the weight. Weight is mass times gravity only. So weight is mass times gravity. So we say weight is equal to mass, which is 4.8. Gravity they will not give you. I keep saying this. In most of them, sometimes you find it at the back of the paper, the top, the first page. They put the value there. Times gravity, which is 10. For IGCSE, approximately we take 10. On Earth, gravity on Earth is 10. In the moon is 1.6. In outer space is 0. So you have to know this one. Without, even if they don't give you, you should be able to use your discretion. So improvise. You should know them. So we say weight will be 4.8 times 10, which will give us 48 Newton. Remember, weight is a force. Weight is a special type of force. So we write 48 Newton. You don't write the Newton, you lose mark. You don't put it in physics. If you don't put the unit, you lose mark. In fact, if the examiner or the examiner is wicked, he will even give you 0. If it's not wicked, if the mark is 2 marks, he give you 1. If you don't put the unit, because 48 could be 48 oranges or 48 apples. It is only when you put the unit that we know what you have calculated, what you're talking about. It tells us that okay, it's 48 is Newton. You've calculated the weight. Okay, if you don't do that, the examiner is at liberty, is his discretion. He can give you 0 or give you just, it reduces your mark for you. So remember to always write unit in physics. Okay, in math, most times you don't need to write unit, but in physics, this is the difference. In physics, you have to include the units. Okay, so that's for question 3A, Roman figure 1. Let's look at the Roman figure 2A, Roman figure 2, what they want us to do, what they want from us. What the question, you must know what the question wants from you. If you don't know what the question wants from you, you end up solving rubbish or you end up writing rubbish. You must understand what a given question wants from you. And you can only know this if you know what is given to you and what you are looking for. So you must work from the known to the unknown. You work from the known to the unknown. Now let's look at the second one. The second part of the question 3A, Roman figure 2, he said we should calculate the pressure due to the liquid on the base of the container. Pressure that is due to the liquid, pressure due to the liquid on the base of the container. You know when you pour the water or the liquid, specifically, if you pour the liquid in the container, the liquid will exert pressure on the base of the container. So pressure at the base, we have to find. Pressure at the base, we have to find. Remember, we will give you the dimension of the base. And we've just calculated the weight. The weight is a force. And remember, pressure can be calculated by saying pressure P is equal to force over area. Remember, we just calculated pressure exerted on the base, not the pressure on the liquid itself. The pressure of the liquid is exerted on the base. That's what so we can use this pressure formula. Before you say, oh, why are we using this formula is for pressure in a solid. Why are we using it to calculate pressure in liquid? This is what the liquid consists to the solid. We're calculating the pressure on the container at the base of the container. So we can use this formula. So remember, we calculated the force. The force is the weight. The weight you've just calculated, please remember, it means force. Weight is a force. So is what you're going to write here. You say the weight 48 Newton. Okay. If you don't know unit, when you are calculating, you can put the unit so that you can arrive at the unit of pressure. Now you have to calculate the area. You know, they've given you the base dimension. 0.16, 0.12 multiplied by 0.16. So we have to find the area of the base of the container. So we say area will be area of the base will be equal to 0.12 multiplied by 0.16. 0.16 multiplied by 0.12. 0.12 multiplied by 0.16, and then we will get the area of the base. So if you multiply this, you get 0.0192. meters square. 192 meters square. Why meters square? Because it's area. So you bring it here. You put it here 0.0192. So we divide 48 by 0.0192. You put the meter square. Why I'm putting the unit? Just in case you don't know you forgot that Pascal is the unit of pressure, you can use the derived unit to write your final answer. In case you forget that Pascal is the unit of pressure, you can use the derived unit to write your final answer. Okay, this is equal to 48 divided by 0.0192. What do we get? 2,500. We get 2,500 Pascal. Now, let's assume you don't know or you forgot that the unit of pressure is Pascal. Let's say you forgot, or you don't remember, or you don't know. So what you can write, if you don't know, you can write 2,500 Newton over meter square. 2,000. Let me rewrite it here. You can write P. Let's use a different coloration. You can write P equal to 2,500 Newton. You remember you are writing the Newton for, because 1 Pascal equals to 1 Newton meter per 1 Newton per meter square. So if you don't know that Pascal is the unit, please write the derived unit. Instead of leaving it blank, you don't write unit because you lose marks or you lose the whole marks. So instead of leaving it like you don't write anything, you write Newton per meter square. So it's still the same, it's still correct. If you write Newton per meter square, you are still correct. Is that okay? But if you remember that Pascal is the unit of pressure, then you write Pascal, better for you. Okay? So this or this, whichever you write, you're still correct. Whichever you write, you're still correct. Okay? Okay, now let's go to 3B, question 3B. I think we're done with question 3A. Question 3B says, explain why the total pressure on the base of the container is greater than the value calculated in the one. Why? There could be only one reason why that will happen. The only one reason why the pressure at the base is greater than the pressure 2,500. So the reason could be, or it is 3B. The reason is because atmospheric pressure is also RT on the container. Because atmospheric, it's not only the pressure due to the liquid, also atmospheric pressure. Presence of atmospheric pressure. So if you write that, you get the mark. I think it's just a mark, right? Presence of atmospheric pressure. Or you can say atmospheric pressure is also acting on it. You just say atmospheric pressure is also acting on the liquid. Atmospheric pressure is also acting on the liquid. So when you write this, you get that extra mark, because that's why the value will ultimately be greater than the 2,500 that we just calculated. That's why the value of the total pressure that is acting on the container will be, they might even ask you to calculate the total pressure acting at the base of the container if they give you the atmospheric pressure. Then if they do that, we add the atmospheric pressure plus the pressure we just calculated. The presence of atmospheric pressure makes the value to be greater than the value we just calculated. Okay, now let's go to C, question C, if there's any question in C. You see, this is just 1 mark, so you just need 1 point. You just need to make a point. You don't need to waste time in this type of question. Now, the depth of the liquid in the container is 0.32, the depth. Calculate the density of the liquid. They've given you H. H is the depth. Okay? They've given you H. H is equal to 0.32. H is 0.32 meter. Remember, pressure of liquid, okay, let's change the color now. Remember, pressure of liquid is rho GH. Rho is the density of the liquid. Is rho GH. Rho GH. The pressure acting on the liquid is rho GH. Okay? And where rho is the density of the liquid. Right? So we're going to substitute the values here. You remember we got the pressure, 2,500. Okay? And we are looking for the density. And we know gravity to be 10. And they've given us the height. So substituting here, we find H. And sorry, we find rho, which is the density. We substitute here 2,500, which is the pressure we've just calculated. We say is equal to the density, which we don't know. Okay, we use this symbol to represent density, rho. Okay, times the gravity, which is 10, times gravity, which is 10, times the height, which they've just given us to be 0. I think the height is 0.32. The height 0.32. Okay, we can double check if the height is actually 0.32. Think so. Okay, so times this. So if you multiply this, you get 3.2. So I have 2,500, which is the pressure. The pressure 2,500 is equal to 3.2, because 10 multiplied by 0.32 is 3.2. So I get 3.2 times the rho, which is the density. So to get the density, we're going to make the rho the subject of formula. We're going to make it the subject of formula. So in doing so, we divide both sides by 3.2. So I divide the left side and the right side by 3.2 in order to get my density, in order to calculate the density. Okay, so divide here also by 3.2. 2,500 divided by 3.2, what do we get? Okay, so here we divide, this one cancel this one, so we say density, which is rho, density, which is rho, okay, it's like elongated E, is equal to what? Okay, 781.25. You know, you have to know the unit of density, right? Density is mass over volume, so it will be kilogram per meter cube. Kilogram per, the unit is kilogram per meter cube. Okay, you can leave your answer like this, but in Cambridge they will approximate this to the nearest 10. Okay, this will be probably, they will approximate this, they will make it 780. But whether you leave at 781, it's correct, okay? It's the same thing. Cambridge, they like to approximate numbers to nearest to number nearest to. Okay, this will become per meter cube. Okay, any answer, any of this is okay. So that's that for the density that they've asked us to calculate. That's that for the density. Now we go to the next question. I think question 3 is done. Yeah, the tutor, you get all your marks for question 3. I think maybe we stop at question 4 today, right? Or question 5. Let's see. Let's attempt question 4 first. It depends. If it doesn't take much time, we include question 5. Now it said describe the movement of the molecule in a solid. Oh wow, this is a free question, right? Solid. And you check the marks. If the mark is 3, you must give 3 points. If the mark is 2, you have to give 2 points. It's just 1 mark. So just say molecules in solid vibrates in fixed position. Finish. vibrate. Just put once they see vibration, you've got it that mark. So we say question 4. We say question 4A. Roman figure 1, right? I think it's a Roman figure 1 question. So we say molecule vibrate. So I will just write vibrate, okay, for the sake of this righty board is slippery, and so I just write vibrate. Say vibrate. Okay, but in your case you can say the molecules in solid vibrate by a fixed position. Now let's go to the Roman figure 2 questions. Let's go to the next one, the Roman figure 2 questions. Okay, describe the movement of the molecule in gas. Now, this is 2 marks. We must give at least 2 points. We must give what? At least 2 points. Right? In gas, we say the molecule, they move randomly in all directions. That's the first point. In gas. For gas, this is for solid. This is for solid. This is for solid. Then for gas, Roman figure 2. For gas, we say they move randomly in all directions. So for gas, the first point we make, we say the molecule move randomly or zigzagly. Randomly. This is R, okay? It's not V. This is R. Randomly or zigzagly or haphazardly in all direction. In all direction. That's 1 point. In all direction. Not one direction, in all direction. They move randomly, zigzagly, haphazardly. You can use this terminology, in all direction. You cannot write only this and leave. You only get 1 mark. You will not get the 2 marks. Because it's 2 marks, we must give 2 points. Okay, if you want to pass Cambridge, you must be looking at the marks. You must give 2 points. This is 2 marks. Okay, so if you give only this and you leave, you only get 1/2. And it's pretty easy. Probably you would have been able to get your 2 marks. Because of carelessness, you lose the second mark. Then you can write, they move with high speed. You can say they move in a straight line, they move in high speed. So let's use high speed because they're very fast in gas, the speed. Okay, high speed. The molecules, they move with high speed. You can talk about their collision. They collide with one another and they collide with the walls of the container. Hence the result of pressure. You can write any of those. They only need 2. If you write these 2, you get your 2 marks. So let's move on. Is that okay? You can say they move in a straight line. They say they move freely. They are free to move. They are very free to move. Any of this point you write, you're going to get your marks complete. Now let's move on. The B is a closed box contains gas molecule. A closed box contains gas molecules. Explain in terms of momentum how the molecules exert a pressure on the walls of the box. Okay. First of all, in terms of momentum is mass times velocity. Okay. So explain in terms of momentum how the molecules exert a pressure on the walls of the box. Okay, B. First of all, we have to check how many marks? 4 marks. So we must give 4 points. We must give 4 points. If you write 1 mark, 1 point, 2 point, you're not going to maximize your marks. So that's why you see some students, they're very brilliant, they're very good with their studies, but they get B or C in exam. Where some students, you think the average students, they get B or A in the exam. So you have to develop speed and accuracy. You must look very well. You must say how many marks that question carries before you know what answers or how you're going to provide your answer. So So for these 4 marks, we're going to provide 4 points. First of all, we say the molecule, they collide with the wall. That's your first point, collide. Collision with the wall of the container. Collision with the wall. The molecule, as they move randomly, they collide with each other and they collide with the wall of the container. So that's the first part, collision with the wall. I will abbreviate it instead of writing with each other, with the walls of the container. I'll just write they collide with the wall of the container. They collide with the wall, okay, of the container. Okay, so we can also say when they collide with the wall, they bounce off. They can bounce off. That's our first point. Now let's go to second point. We must try our best to make 4 points in order to get the 4 marks. The next one is that when they do this, there will be, when they hit the wall, let's say this is the container, the gas molecule, they're moving. Okay, the gas molecule as they move. Let's say this is a gas molecule with an arrow. This is another gas molecule. So when they hit the wall, see this is the wall. When they hit the wall of the container, what happens? They will bounce off. They will bounce off, right? The molecule will bounce off and start going in another direction. And maybe it will hit another molecule. It will hit another molecule that will not go in here again. Hit the wall and bounce off. So this is zigzag motion. It will be in a straight line. Okay, so we say when this hit the wall, bounce off, there will be what we call change of momentum. We say change of momentum will happen. Change of momentum will occur. So we write that point because remember in the question they measure momentum. So logically we should find in our answer to measure momentum. That's how to be smart with exam questions. They measure momentum in the question. So we say there will be change of momentum. There will be change because they hit the wall and they bounce off. Momentum is your movement, your speed when an object is moving. Okay, what you have when you're moving. So when you hit the wall, your speed will change, your direction will change. So we say there is change of momentum. That's the second point. So we're going to get 2 marks so far for writing these 2 points. Sorry, I'm writing momentum again. There will be change of momentum. Let me erase this. Change of momentum. We get our second mark. Change of momentum. There will be change of momentum. There will be change of momentum. That's the second point. The third point. The force hit the wall in a specific area, right? Force, there will be a force on the wall, exerted on the wall. So when force is exerted on the wall, it will be force over an area will result. You say force over an area will occur. Force over an area will occur. Because the force, the molecule hit the wall with a force and with a hit on a specific area. So you say force over an area will occur. Okay? Force over an area. There will be a force over an area. Or what you call the total change of momentum per second. Or you can call this total change of momentum per second. So in other words, you can say momentum, change of momentum per second. There will be, you can write this, change of momentum per second. This one, you can write this way or call. So it's connected to the third point. Now the fourth point, we talk about the pressure now. Pressure will be the total force that has happened, the total force over the total area. This one is for each individual molecule. You will occur per molecule. Per per molecule. Per molecule. For one molecule. But many molecules will be doing the same thing. That's the fourth point. This per molecule. The fourth point is that almost all the molecules will be having force per area. Force per area. Molecule. Okay, this is for per molecule. Now the fourth point is that all the molecules will be having this force over area. All the molecules, fourth point, will be all the molecules. So we can say there will be a total force. Total force means all the molecules will contribute to this force over an area. Total force, there will be a total force per total area. Total force, there will be a total force over the total area. There will be a total force divided by total area of the walls. Why we say this one? This is not per molecule now. This is for all the molecules. All the molecules force over area, which is pressure over total area. Total area of the wall. Total area of the wall. Yeah, just write total area, which will result to overall pressure. Which will result to overall pressure. Which will result to the overall pressure of the molecules. So when you write this, you get your 4 points. Which will result to overall pressure. So which will result to overall pressure. Remember, point 3 and point 4 is just logic you use. Force over area will occur per molecule, and the total force over total area will occur per all the molecule, which is pressure. Both 3 and 4 are pressure, but this pressure per molecule, and this is the total pressure. So when you do this, you get your 4 marks. You get your 4 marks. I think we're done with question 4. I think we're done with question 4. So we think with this we come to the end of this section. Thank you for joining us.